So what happens when a figure or you change the dimensions so that it is not proportional, right? So what happens when you don't when instead of changing all the dimensions, you only change one? Um, it kind of just depends on which dimension you're changing and how it's going to affect the rest of the shape compared to the original. So here it says, for the first one, it says how many times larger is the volume. Okay, so volume is telling me which formula I'm going to use. Cylinder is telling me the volume of a cylinder is what I'm going to be using, right? So we start off with volume of a cylinder, which is pi radius squared times height, right? So area of the base times height of the prism. And it says if the height is doubled. So what we're going to do is we start off with the original, and whatever they tell us to do, that's gonna be our new volume, right? With whatever they're telling us to do, which whatever the dimensional change is included in here, and then we're gonna compare them, right? So in this case, the base is not being changed; it's still pi r squared. The height is being doubled. So if the height is being doubled, it's just 2 times the height, right? And we kind of do a little simplifying here, and we end up with 2 pi r squared times height. And so essentially what we're doing is we're comparing, and the easiest way to do it is compare what changed, right? What's different. The official way to do it is compare your new one, which is 2 pi r squared over h, and compare it to the old one, or divided by the old one, pi r squared h, and see what's happening, right? So the pi r squared h cancel out, and here we're left with 2, right? But if you notice from the very beginning, that was the only thing that was different compared to the original one, right? So here, what it says, how many times larger? Well, we can say it's going to be 2 times larger, right? So again, it has nothing to do with squaring it every time or cubing it every time. It kind of just, you start off with the original formula, and then the next one that you're going to compare it to is with that change included in there, right? So let's look at the second one. It says how many times larger is the volume of a pyramid, or of a square pyramid, right? So first of all, we're going to start off with a volume formula for a pyramid, which is 1/3 base times height. Now, what we got to worry about, we can't leave it as base, right? So they're telling you it's a square pyramid, so that's just telling me that's the base of my pyramid, right? And so the base, we'll call it s, right? And then so to find the area of that base is just s squared. So I'm going to rewrite my original formula for volume as 1/3 side squared, times height of the pyramid, right? And so that's the original one. The new one, they're telling you if the edge is tripled, right? So if one of these edges is 3 times s, right? And so we can't, what we got to worry about here is that if you are going to triple the edge, that means you're tripling all of them, right? And so here would be 1/3 my 3 times the edge squared times height, right? Now, and so once again, we're going to kind of simplify a little bit and go from there. So we're going to distribute the square, and that's going to give us 9s psi squared equals to h. And once again, officially we can simplify or divide, right? But what we're actually doing is seeing what's different, right? So the 1/3 s squared, h is here, and so really the only thing that's different is this 9. And so that's telling me that it is going to be 9 times larger, right? Officially, if you wanted to actually solve it or simplify it, right? So this would give us, so we already have our answer. This is kind of a little bit extra. So this would give us 3s squared over h for the new volume, right? And then if I were to divide them over, we get 3s squared times the height over 1/3 s squared height. These cancel, so now we're looking at 3 divided by 1/3, which I can rewrite as 3 divided by 1/3. That's technically over 1. That goes to the top, that goes to the bottom, and we still get 9. or 9 over 1, or just 9, right? Looking at the last one, we approach it the same exact way. It says, how many times smaller is the surface area of a sphere, right? So surface area of a sphere is going to be 4 pi radius squared. And it's telling you the radius, there's only one dimension, the radius is multiplied by 1/2, right? So that's our original one. Our new one is going to be 4 pi radius is 1/2 times the radius squared, right? And again, we're going to distribute the square, so we get 4 pi, and then we have 1/4 radius squared. And again, we are comparing to figure out what's different, right? So the 4 pi r squared, 4 pi r squared is there, so the only thing that's different is 1/4, right? Now, once again, here we have to be careful. We end up with 1/4, which is correct, because we know we have a reduction because they're telling you how much more smaller, right? So the 1/4 confirms that we did have a reduction, but the 4 is telling you how much of a reaction. So here we can say 4 times smaller.